Thank you to everyone for attending the Industry Leader Lecture Series via Zoom. For those attending, please take a moment to ensure your full name, first and last, is shown in your Zoom window. This will help us with attendance and also for sending out future communications. As a reminder, the session will be recorded. All questions will be answered at the end of the presentation, and you can direct them to the Q&A chat box below. For all student attendees, if you attend 2 of the 3 sessions this semester, you are eligible for a certificate of completion signed off by the Dean of the College of Engineering and Computing Sciences upon request at the end of the last lecture of the semester. All attendees are automatically entered into a raffle for NYIT swag items, and the winner will be notified via email. You must change your name in your Zoom window to your full name to be eligible for the raffle. Now I'd like to introduce the Dean of the College of Engineering and Computing Sciences, Dr. Babak Beheshti.
Thank you, Sarah. And good afternoon, everyone. It is my pleasure to welcome everyone to the second session of the Fall 2022 series of the Industry Leaders Talk series hosted by the New York Institute of Technology's College of Engineering and Computing Sciences, as well as the IEEE Region 1. My name is Babak Beheshti, Dean of the College. As I mentioned, this series is co-hosted by our college and the IEEE Region 1. Our audience today is composed of IEEE professional members, as well as student members from across the Northeastern United States, in addition to the College of Engineering's current students, alumni, faculty, staff, and a number of distinguished guests. I would like to thank the College of Engineering's Dean's Executive Advisory Board, particularly its chair, Dr. Robert DeFazio, who has been instrumental in organizing this series. Today's Industry Leader presentation is titled A Global Perspective on Critical Power System Infrastructure for Next Generation Computing. The speaker is Mr. Peter Curtis. Peter is the founder of PMC Group LLC, an engineering, research, and technology company. He is a College of Engineering and Computing Sciences double alum. Peter has over 30 years of experience in the mission-critical engineering industry in the areas of banking, finance, defense, electric, water, utilities, transportation, energy management, education, and product development. Please review Peter's impressive bio sketch available on the event website. Without any further ado, I will pass it on to Peter. Peter, go ahead, please.
Thank you, and welcome everybody. Thank you for taking the time to learn more about critical infrastructure that sustains the way we live our lives and how computing, infrastructure, and the cloud are woven into everything we touch, from the electrons that travel through the fiber to transmit this presentation, and you to me, and me to you, all over the world through enterprise data centers. It used to be said that money makes the world go round. Today, information drives the world economy and much more. Oil and electricity, as we know, lights, heats, cools, and powers our homes and businesses. It makes every piece of plastic, every computer chip. It carves every beam of steel and wood and produces every bite of food that we eat. It delivers every drop of water we drink. With the antiquated electrical grid, extreme weather patterns changing, and the explosion in computing due to AI, quantum, blockchain, crypto, meta, IoT, AR, VR, and robotics, we have the perfect storm unfolding right before our eyes, and that's just part of the story. Factor in supply chain issues, half the industry retiring in the near future, and as always, the things we can't predict, such as a pandemic that essentially shut down the world and accelerated an even faster growth in technology. I still believe we haven't come close to the norm in computing. We have no idea where this is going, but we know that it's increasing 2- and 3-fold over the next decade or two. Regardless of how electricity is produced, the more interesting story here is how the cloud has emerged as a major and fast-growing consuming infrastructure. The entire ecosystem associated with the cloud already consumes about 10% of the global electricity. Think about how that 10% contributes to the global economy. So I was asked today to talk about my book, third edition, Maintaining Mission Critical Systems in a 24/7 Environment. This book is used globally as a reference and handbook to deliver standardization and culture for an industry that's still defining itself. It also provides the best operational practices and overview of critical infrastructure that allows us to compute most of the time seamlessly in an industry where downtime is not acceptable. 10 minutes of downtime a year for a major company could make the difference between a loss and a profit for that particular year. Not to mention how first responders and other agencies that use critical infrastructure need this to be provided um, without issue. So we talked about this particular slide. So this is basically where we're at right now. And so I have an engineering lens, I have an education lens, I have many different lenses based on the clients we've worked with over the years, the challenges that we've had, myself managing corporate global data centers through the years. And so the overall idea of the book is to provide proper culture and standardization for our industry. And the industry is still defining itself. So basically, if you look at the right-hand side of the screen, we have operations and infrastructure. It's kind of cut off. But when you look at online learning, cybersecurity, robotics, transition operations, culture, standardization, this is all the things that we need to be incorporating day in and day out. Because with this knowledge, it's getting information from generators, UPS systems, raised floor cooling, fuel systems, and on it goes. It touches every piece of equipment and every vertical in the world. Basically, here we are with this particular slide. We want to talk about how it begins with people. And the mission critical industry will lose half of its workforce this decade. And the story gets more interesting. The industry is also under the radar. Kids graduating high school don't even know that this industry exists. But to me, it's the new mission control. And the new mission control with some really cool command centers, awesome technology, analytic tools, and most importantly, well-paying jobs for the trades and professional workforce. And it also offers a lifetime of growth. When you think about all the industries in the world, this particular industry is driving commerce, healthcare, everything that we do, the way we live. The people entering this profession need to be trained like first responders, nuclear plant operators, healthcare professionals, airline pilots, to name a few, which is one of the reasons that it inspired me to write this book starting back in 2007. I can't believe how much time has passed. With that in mind, I want to make sure that people understand that the electrons that make this world hum actually pass through the hands of the mission critical trades and professionals that are in this particular industry. It's kind of overwhelming today, the news that you read, particularly when it comes to cyber threats and the impact it can have on processing and critical infrastructure. Whether it's a pandemic, a hurricane, a power interruption, or man-made events. It touches every business, no matter what's happening. Without these critical infrastructures, the cloud, we can't have a normal society that we are in right now. A few examples recently is equipment failures that knock out a busy airport, 48-hour power shutdowns due to fires, data center backup. These are all challenges, not including the natural events with the various hurricanes that occur, the blackout, if you remember years ago, the blackout that occurred at the Super Bowl. This is based on testing, commissioning of systems that were not processed properly. Tornadoes. So the potential causes of load interruption or downtime come from four categories. It's human error, it's equipment failure, it's natural disasters, it's catastrophic events. So these are all challenges that we have to face every day, and that no matter what is going on, we have to, as a industry, be able to be prepared, be aware, and be able to visualize no matter what is going on. If we can't do that, then we can't respond appropriately with the proper situational awareness. So you ask yourself, if you don't have a properly trained person or personnel when a critical event is occurring, what is the results of that person's actions? So whether it's safety, downtime, financial loss, it doesn't matter. System damage, it doesn't matter. You have an impact. And as soon as you walk into that critical infrastructure, whatever you touch has an impact on how information is processed. And so there's a whole mindset that needs to be available and people need to be aware when they enter this industry. This industry could be stressful, but it could be also very rewarding when you think about what you do as a mission critical engineer, whether you're a skilled tradesperson or you are a person that's a professional running the operations of these critical infrastructures. It's so important to understand what your impact is. And the impact could come from the financial department, not approving a purchase order to do maintenance on a piece of equipment. However, they don't understand perhaps that maintenance that needs to be done on that equipment will shut the equipment down if it's not done. So everything has to have a life cycle schedule from a maintenance standpoint. The cool thing today is we have infrastructure, IoT technology, sensors that allow us to do random sampling of equipment so we could understand what we have to do in order to reduce risk for our organizations. This particular slide talks about the market. And I had to look up this number at least a half a dozen times before I was comfortable putting it in this presentation. The top left, IT spending is $4.5 trillion in 2022. That number is going to continue to grow, 4.5 trillion. To give you an example, we might be in $20 trillion of debt right now as a country. This represents 25% of a number that is that huge. When we look at data center spending, it's $226 billion. 71% of the people that were interviewed felt like their needs were not being met internally within critical infrastructure with the challenges that they face. 89% that felt that they were not ready for the future. We have over 4,500 data centers worldwide. These are the large ones I'm talking about. 5.6 million commercial buildings in the US. But again, the photo or illustration to the right, this is Loudoun County, Virginia. This is one of the fastest growing areas of the world with regards to data center campuses. Loudoun, Virginia has some really good incentives for people to move their data centering and processing at this particular location. However, that being said, the utilities now are under extreme stress because they can't meet all the supply needs. When you look at a facility like this, I was at this particular site a few months ago. You could walk down this, because this could be a mile radius with this particular campus. And you could walk down, you could see 50 megawatts of standby generator power, thousands upon thousands of tons of cooling. The processing that's going on inside these data centers is, in some case, 20% of what a power plant would be, a large power plant. For instance, Shoreham Nuclear Power Plant, that was 800 megawatts of electricity. There's a place around the world right now that's building a 800 megawatt data center. It's just amazing what is happening because of the processing, the cloud, how we're relying on critical infrastructure day in and day out today. It's just amazing. This is another screenshot of other campuses in this area in Loudoun, Virginia. And you can see there's three areas here, one to the left, one right in front of us, and one to the right. And again, this is, when you look at this, think about a nuclear power plant and how large a nuclear power plant is, because that's the power that this takes. Not even thinking about the processing part of this, where we have over 200,000 processes that are approximately 100 watts each. And that's for a small type of data center. When you think about these data centers and critical infrastructure, one of the things to understand is that a square foot of a data center inhales as much electricity as a square foot of a skyscraper and rents for 5 times as much. So it inhales 100 times as much electricity as 1 square foot of a skyscraper. That is an amazing number. That's an amazing number. When you look at a data center, every 30 seconds, this global internet transports the equivalent of the Library of Congress every 30 seconds. This is what's happening as we are utilizing our critical infrastructure and processing and compute power available. What is really challenging in this industry right now, we cannot find enough people to manage and operate these critical infrastructures. So there's a real opportunity here for really great paying jobs and to augment this information into electrical, mechanical, civil engineering programs, computer science degrees. And again, with us losing half the people this decade, how are we going to sustain what we do? Well, part of that will come from automation. Part of it will come from robotics, but we still need people. People still need to bridge the gap between technology and machine. People are the best sensors. They do understand. We do understand how we need to be involved, but we can't be doing the mundane things anymore. When you look at the size of these data centers, to walk from one end to another could take you a half an hour to 45 minutes. It would be much nicer to have a robot that's armed with infrared scanning, cameras, ultrasonic sensors, and more to push information back into a database that identifies risk that could be associated with a critical infrastructure. The human challenge, the human error, and legacy systems are certainly an issue. Today we have legacy data centers, we have hyperscale data centers, and the legacy data centers could be 20, 30 megawatts. A hyperscale data center could be 150 to 200 megawatts of electricity. It's just insane what's going on in the industry. And for me to be here and be able to visit these critical infrastructures and understand what's going on and be part of a solution with the various education and engineering technology that we provide, it's a really cool. I find it very purposeful to be able to be involved to the level I am and to be able to look at and visit almost every single vertical type of company in the world and know that this information, this processing allows this world to hum the way we do. The challenge that we have now is the supply chain, cybersecurity. These are huge, huge problems right now. We're getting hacked thousands of times a minute. And the more important your business, the more it will be, people will try to hack into it. So the cybersecurity industry is another industry that will at least triple to quadruple in size in this next decade and a half. Again, amazing things that are going on here. When we look at the old legacy type of data centers and supply chain issues, I think the legacy type of data centers are opportunities to enhance and utilize something that's already built. And when you look at it from an environmental, social, and governance standpoint, to be able to reuse buildings and infrastructure and perhaps update equipment if possible, depending upon the life cycle of it, I think we have a chance to continue to move forward with this environmental, social, and governance goals that lots of corporate America has. When you look at the right-hand side of this slide, the challenges that are most negatively impacting reliability and the cause of downtime, it's security. The biggest one of the biggest ones is human error. it's so important that we educate and create a situational awareness for the people that operate and maintain these data centers. We must keep these people safe and secure. So we have to train them on the safety aspects of it. The challenge is some of these jobs are hands-on, and we need to be able to ensure that we've got the right personal protective equipment that we're wearing. We understand the energy behind this equipment. When you have an explosion from a piece of switchgear that's running the critical infrastructures, that could be as strong as a tornado coming right in your path. So we have to make sure that we have the right processes in place, the right, don't open up equipment cabinet if you don't need to. Rely more on sensors as we can, but it needs to be built into the manufacturing process. And that's part of the challenge as we evolve. But as we continue to evolve and manufacturing begins to incorporate IoT sensors and other types of sensors that are looking at equipment and electrical signatures inside the equipment on a second by second basis, a millisecond basis, or minute by minute, depending upon what you need to see, becomes important, and it becomes also a great tool, because just because you're not opening up the equipment, it still means that you're monitoring even more than you were before. And so every time you open up that piece of equipment and you have electricity running or energy behind it running, you need to ensure that you're safe. And the minimal amount of time that you open up that equipment will be reduced risk within your organization. So as I mentioned earlier, 65% of all the downtime and greater is because of human error. So we need to continue to improve that, and that will be improved by the various sensors, equipment, monitoring digitally, automatedly, robotics. So those are all the things that will lower that 65% of downtime. The other challenge here is that the infrastructure that touches every industry years ago was quite complex. We're trying to make things simpler today, and it's imperative that the new systems have a standardized design. There's a culture within an enterprise, an organization, an enterprise. So when you look at this particular slide, we're showing that we touch every single industry. Mission critical engineering touches every single industry in the world. And so it's imperative that we educate the next generation of mission critical professionals and provide them with the right tools, technology, techniques to help them reduce risk and create that enterprise culture and standardization, and make it consistency through an enterprise and through an industry. And that's really the goal for the rest of my time before I retire, which I don't feel like I have enough time to. It's got to be another at least 10 years that I do this to get the industry where I want it to be, and to make my contribution. And talking about contributions, I do want to take a moment to thank the people that contributed to my book. I did the best I could, and then I got a 360-degree overview. So the material that you see here, the material in the book, I've had lots of eyes look at it to make sure I wasn't going down a lone wolf path. I wanted to make sure that we got a 360-degree perspective, and I got it right. But my background in this industry, working for electric utilities, water utilities, banking and finance, teaching for a number of years, writing the books, and then learning from my clients, learning from my students over the years. That's all in part of what we do today and what I contribute to the industry today. So it's really important to understand that I've had help, and I want to thank the people that have helped me. In addition to that, getting back to this particular slide, I want to make everyone aware that when you look at the cost to build these critical infrastructures, years ago, we could have spent maybe $15, $20 million to build a 2 to 5 megawatt data center. Today, we are spending 1 billion to $2 billion to design and build these hyperscale data centers. And when you look at where it is, where these being built, today it's being built in places all over the world, whether it's Seattle, whether it's in Arizona, Loudoun, Virginia. It doesn't matter. They're being built, and they're being built at a scale that is huge. It's kind of the next generation of what we would see when we thought about super critical technology years ago. We thought about NASA, the Johnson Space Center, things of that nature. This industry is that today. This industry is the new mission control for the globe, the economy, first responders, healthcare, financial services. This is the new NASA, as I would say, of the world. And the command centers that NASA used years ago rival what we are using today to manage these hyperscale data centers. It's simply amazing. And when we think about how we sent men to the moon years ago, and the technology that will fit on your cell phone today, and the technology that we have to make this world hum, it's so incredible. I am befuddled every day how we have grown from where we were back in the early 1990s, then escalating to Y2K, if anyone remembers all the testing that had to be done. And it just wasn't tested on critical infrastructure. What about the people that had pacemakers in there and relying on that for their healthcare? Today, we have people that are diabetic. They have patches that they could put in their bodies, and that would feed back to a doctor, and the doctor would let these patients know that, hey, you might have an issue. But here's some of the things that are driving the growth of the industry. When you think about that type of technology, the IoT piece of how things are growing, it's just, when we talk about twofold growth, I don't think it's twofold growth. I think it's 3 to 4-fold growth in the next decade. And so when you think about 3 to 4-fold growth, what does that mean for the computing world? We haven't talked about artificial intelligence, machine learning, all the various algorithms that need to be written. It's all part of what's driving computing. So we have ahead of us a very exciting time, but we also have a very, very challenging time to get the people in this industry focused that, hey, this type of job today is almost as important as being a doctor, being a police officer, because again, this secures everything we do and the way of life we want to live. So those are the things that, drive me to continue to innovate and bring new product and technology to the market. To me, it's probably one of the most important contributions that we as an industry can make to the globe to keep this society humming with all the various technologies that are coming on, the critical infrastructure that needs to be upgraded, the antiquated electrical systems that were built for a manufacturing society and not a digital society. So we can't point the fingers at the utilities. What we need to do, and maybe what the utilities need to consider, is perhaps being in another business and providing critical pure power to these hyperscale data centers. The people that run these data centers don't necessarily want to be in the power business, but guess what? When you run a 100, 200 megawatt facility based on all these industries, this is a power plant. And so people that aren't trained like nuclear plant operators and trained, they're brought up, they have to come up to speed and how to operate, maintain, and provide the appropriate maintenance and keep people safe. Part of the other reason that drove me to write the books and talk about a lot about safety in this book is I've known people that have gotten electrocuted and burned half their body because of it. Luckily, they didn't die, but they're disabled today. And I've known a handful of people that have had these issues. And again, it comes from safety protocols, systems called lockout, tagout. We just need to make sure that we isolate power and any type of energy before we have to do any maintenance on it. And again, look at all the different industries that we have here, whether it's information technology, healthcare, manufacturing. And what I just realized I don't have on this slide is the hyperscale data centers. It's just amazing. So my goal and the goal of our industry is to advance the mission critical professional and provide proper facilities process management so people can be aware, be prepared, understand, and that is provided through proper education and training that's standardized throughout higher education, bringing people in, letting the kids from high school know that this industry exists. We want people to be aware, and we want people to understand through visualization. So I talked about a command center before. You can see the top right of the screen. We have a semblance of a few screens similar to what a trader at a banking and finance company would have. But when you look at one of these command centers, you could have 1,000 screens in there, and each one of these screens are bringing disparate sources of information and other software platforms together in order to be able to provide the visualization and user interface that is required to see an urban telepresence, provide enhanced decision making, just help reduce the time it takes you to react to a critical event. That's the main goal. There's always going to be critical events, but how do we respond with a situational awareness? And that's just training every day. One thing that I am working on are what I call micro lessons. So I'm taking my book material, I'm creating 15-minute micro lessons. So when people do their rounds and readings at these hyperscale and legacy data centers, they are able to, when they finish their shift, learn for 15 minutes every single day. So you have that continuous improvement process involved in the professional and trades growth every single day. I can't say enough about the tradespeople that manage and work in this industry. They're really drinking out of a fire hose sometimes, and especially when a critical event occurs. So we have to really thank them. They're like our first responders. They are our boots on the ground that allows us to ensure that we can respond effectively. But again, the training that's necessary in order to do this, it's just not 1 or 2 classes. It's continuous. Before a person is familiar with a 1 to 2 million square foot infrastructure, it could take that person a year, 18 months to really know the nuances of that facility. And so how do you train? How do you onboard people? So when you think about that year to 18 months that it takes you to learn that facility, and you think about the wisdom that is leaving this industry over the next 7 years, call it, we're losing a lot. So one of the things that we need to be able to do is digitize the wisdom that the people that are leaving and bring it into a technology that allows easy onboarding of people as they come into this industry and continued learning. So it's the training, it's the operation, it's the visualization that are imperative to keeping the globe running the way we want it, and also being sure that we are available to respond when critical events unfold. I just want to share a little bit of what I'm doing personally and what I've personally invested in over the years. Education and training, knowledge transfer. So this really marries nicely with the people with wisdom. So part of what we're doing with some of our clients is they have said, hey, my people that are retiring, they don't want to learn new technology. It's not for them. They realize that they're retiring and it's just too much for them to absorb at this time. So one of the things that we could do from a collegiate and corporate standpoint is we could marry engineering students with the people with wisdom. So the kids, they know technology. The people with wisdom, they have the knowledge. To marry these people together to do that knowledge transfer and digitize what they have in their head on that 1 to 2 million square foot facility allows for a great marriage from a standpoint of onboarding that next generation engineer. The next thing that we want to do, okay, we have that piece done. We want to be able to look at the operational piece. We need to automate as much as possible. Some people that are in, not people, companies that are in this industry, and I would say at least half, are still doing their rounds and readings with paper. You can't set thresholds, you can't react, you don't have the proper tools at your fingertips. So what you need to do is you need to be able to automate that process. You need to be able to audit, assess, and you need to do it on an enterprise level. Whether it's for 100 facilities or 1,000 facilities, we need to be able to get these types of assessments done rapidly. So operations and the digitization of operations is imperative at this point. The center slide of visualization, we're looking at an airport, we're looking at a convention center, we're looking at a city, and we're looking at IoT. We need to be able to visualize what's going on in our world. So a couple of slides ago, I talked about every single industry. Well, for each one of those industries, they have a specialization, a unique user interface that they need to see. And then lastly, when it comes to robotics, IoT, drones, there's a place for this, and people should not be scared about having a robot within a facility. Like I said before, it could take a person a half an hour to go to the other end of a facility to see if there's a leaking pipe or an unusual noise. Send a robot there, have the robots in quadrants, have the robot armed with the proper sensors and cameras that report back to a database that identify risks through algorithms that are written. So that's one part. Another part is the drones. It's terrible to say this, but look at what has happened with the schools and the terrorism that's occurred at some of the schools. Have drones flying over and just having a library inside that drone of unusual activities. So such as a person with an overcoat that may have an assault rifle, or a person that is walking back and forth and drops a briefcase and then walks away. Those are alerts. That's intelligent stuff that could be used today. The ring that I'm wearing here today is an Aura ring. We're interfacing technology with the ring today that allows temperature of a person, the heart rate of a person, the blood oxygen level. These are things that this ring can do. So if you marry 2 or 3 of these together and a person's going on site and all of a sudden they get alerted, hey, you may have a fever. Maybe you don't want to go into that. Maybe you want to say instead, hey, maybe you want to take a COVID test before you infect anybody. It's not predicting COVID, but you might have 2 or 3 variables that could cause that issue. So there's technologies here that can make the world safer and better. Unfortunately, we've got to deal with some of the things that we deal with, but that's just part of the world we live in today. So this is a couple of other screenshots. Again, we're raising a building here. We're providing information on an IoT sensor, and we're talking about right in the palm of your hand what you need to have in order to operate these critical infrastructures. This is the urban telepresence. Again, what's going on outside my building? What do I need to respond to outside the building? So if there's a hurricane coming in, we may want to know what those wave heights are. Is it going to impact? This is downtown Manhattan, obviously. And so maybe it's Hurricane Sandy. It gives us more time to prepare and understand what level of response we need to provide. That's just outside. But then we need to take all the disparate platforms internal to the building and look at that and what action needs to be taken. So with that, I am going to take some questions and answers.
So the first question, can you give examples of human error which you claim to be 65% with an orderly view on priority basis? How do you plan to tackle the human error other than what you informed about education?
Yes, so human error, yes, education is an important part, but training and understanding the equipment that you have and being familiar with the infrastructure that's in your building is imperative. So an example would be you just build this $1 billion facility. When the manufacturers come in and they start up their equipment and you do your system integration testing, let's record how that system operates and how it integrates with other pieces and parts of that system. Let's have that video right from day one. So anyone that's operating the building is on site and they're learning about that. Now, challenges over here is they won't always, you'll have new people always coming and going. But if you are able to record that and the building engineer is brought in while the chief engineer is brought in while the building is being built, they're going to be a phenomenal gap in bridging the human error. So that's one aspect. Another aspect would be having the proper sensors available so that people are looking at a command center and an alert comes up and they can respond appropriately with the situational awareness, which leads to having the proper standard operating procedures, alarm response, alert, emergency action procedures already written. And so for a building like that, you could have 500 procedures. And it's really, really important that you understand it and you take the time to learn it. You can't be expert, but you really need to know how it flows and how it impacts the day-to-day aspects.
Awesome. Next question, a bit of a longer one. The recently published book, California Burning, documents the challenges PG&E faced in the public utility realm, ranging well beyond technology, like engineering economies, public relations, accounting. How should an engineering undergrad think about educating him or herself to prepare for these kinds of challenges beyond core engineering?
Well, my answer to that is to be a constant learner, an avid learner. What we know today will be different than what we know tomorrow. So if I would have stayed back when I graduated college and finished my master's, if I would have just kept that knowledge present in my head and then didn't do anything more, I would not be where I am today, being able to talk about this. So we need to constantly improve. Professionally, we need to always look at what the next step is for our growth and our training. So being able to continue to do that is imperative. Now, the difference is back from, call it the 1940s to 70s, 80s even, things stayed the same for a much longer time. A major invention would occur perhaps every decade. Now a major invention, something new is happening every 3 to 6 months.
How do you control power interruptions that may occur due to natural disasters or hacking by other countries?
Well, that's a really loaded question. Well, first things first. Let's talk about the hacking. We have command centers that are looking, SCADA systems that are looking at utilities. If you think about what happened, perhaps it was 10 years ago in Silicon Valley, where there was actually a terrorism attack on a power plant and transformers that fed Silicon Valley. That is one issue. And I'll bring up another issue, the hacking piece, and then I'll talk about them both together. The hacking, we have to continuously monitor. And not what I mean visually monitor. We have to have ensure the necessary firewalls are in place. Remember years ago, people were hacking into a vending machine that had an IP address and they were able to hack in, and that was on the same network as some of the critical infrastructure. So obviously that's not good. We need to be monitoring in the microseconds of what's going on so we could stop and protect. We need to make sure we have the proper patches on our firewalls as often as possible. And it needs to be automatically updated. We can't wait for the vendor to come in and download the updates. we have to make sure that we're on top of that. And that's just someone's job to continue to monitor that. And listen, we've had issues in this country through hacking, whether it be traffic systems, power plants. It's known, it's printed, it's published. But we need to really be diligent. And it's again, there's machine learning algorithms that need to be hovered over these firewalls that are constantly looking at the systems.
With the advent of the edge data center as opposed to the hyperscale centers, what do you think the future of these smaller local edge centers will look like for people who want to get jobs in the industry? Since the edge centers will be smaller but spread around the country, as opposed to the hyperscale centers in very specific, very rural areas of the country.
Excellent question. The hyperscale data centers aren't going away. You still need that, and you need the edge computing as well. The edge computing is coming around because of a lot of the streaming that we're doing, such as what we're doing today. We need to be closer to the compute supply and storage, and that's so it doesn't impact. It's just another opportunity. So when you look at the communication companies that have lots of thousands of smaller edge facilities opposed to a data center that's doing lots of processing, it's really two different industries. When you look at autonomous vehicles, the edge data centers will be part of that as well. So things that need to be closer to us because of the streaming and processing, those will be in the edge. The high compute processing will be in the hyperscale. The storage will be in the hyperscale type infrastructures.
What is your feel on incorporating battery energy storage systems at data center and grid support in ancillary services, like utilizing the standby gensets for grid support or legislation?
Okay, so that's again another question. Very, very good. Yes, today we have companies that will provide their standby generators to offset peak loads. So I think that's very important. And there are incentives that the utilities will pay for that, and handsomely as well. Because what it does is when you add up all these individual generators, it could make the difference of a couple of power plants during those peak times. So that's a really important part. The battery storage has really become important as well. The battery technology. The thing that concerns me about the battery technology today, we're using it in vehicles and lots of other places, photovoltaics, wind power. The thing that concerns me is most of the material that batteries are built with are not in this country. And so we need to be careful that we start to think about how we can build and get the materials in this country to build those battery systems. So from a reliability standpoint, the lithium-ion batteries today are really great. They take less real estate. They're lighter. You can put them inside a normal room. But I mean, we've got some challenges to overcome that we've been overcoming with them as well. Previously, we had lead acid and valve regulated batteries, and the lead acid would last 20 years, but it would require a ton of maintenance, but very, very reliable if you maintained them properly. The valve regulated batteries that we have are also very, very good, but they're only a 5 to 7 year battery. Some of them are 10, but basically there's something called the bathtub curve. And basically you'll have failures in the very beginning, and then you'll settle in for a number of years, and then you'll have failures at the end. So it is, all the battery technology is good. As everything, it needs to evolve. Lithium ion is the next stage, and lithium ion, obviously for cars, alternative energy, it's very important. And also it's important to mention fuel cells are very, very important. Where you have good quality methane and natural gas in an area, a fuel cell could really, really be good, especially depending upon the type of fuel cell that you use. If you can capture that hot water that it produces, that could be used to offset some of the heating costs and cooling costs. So there are other opportunities. But there's the Bloom box out there is really one of the best out there, but there are other phosphoric acid and other types of fuel cells that are out there that are equivalent. But we need to look at all technologies. We need to be able to look at where we are geographically and where these technologies represent the best alternative.
Do you recommend VR, AR training for simulating a response to tragedy? Technology can lower the percentage of human error, but it'll never reduce it to zero.
Yes, that's a really important. When you look at these critical infrastructures, whether it be a hyperscale data center, a hospital, a hotel, that everyone has a critical infrastructure. So augmented reality, virtual reality, you can build the simulations. One of the things that I'd love to do if I have time in my career is to be able to provide a simulated command center and a simulated critical infrastructure to train the next generation engineer. So they don't have to be in front of the equipment. And it's more of a game because, again, the kids like this type. So if we have like a gaming type situation that, hey, I have to isolate a UPS system from its battery bank number one, how would you do it? That would be in AR, VR to be able to simulate that process and actually go through the training step by step and marry that with the proper standard operating procedure is really a great way to learn.
Awesome. I think we can do one more question. We have IoTs used as sensors, have small processors, and hence do not have processors within IoTs cannot encrypt data. This gives hackers advantages to play their games and to hack into critical infrastructure. How do you ensure this does not happen?
Well, that is really a good question, and I don't have a good answer for that because it's just a little bit out of my realm. But what I can say is making sure you have dedicated networks within your building, and you've got strong cyber passwords on these networks, and you're constantly monitoring those networks. That would be a sense of how you would be able to protect.
Perfect. Thank you so much. That's all the questions we have. Um, I think Dr. Pesci, you can take it away.
Thank you, Sarah. And thank you, Mr. Curtis, for the great presentation. Thank you all for participating in this event. My thanks go to colleagues who made this event happen, Dr. Rob DeFazio, Assistant Dean Jane Polizzi, and the amazing College of Engineering staff, Ms. Jill Rogers and Ms. Sarah Hasasta. Please tune in for the next talk as it will be advertised through the same channels you learned about this talk. Have a great afternoon.
Thank you, everybody.